What if I told you that right now there could be a black hole drifting silently through our galaxy? No light, no signal, no warning, just an invisible mass moving through space, and we would have absolutely no way of knowing. Black holes are the most extreme objects the universe has ever produced. But here is what most people do not realize. They are not all the same. Each type is more extreme than the last, and some of them should not exist at all. Today, we are going through every confirmed and theorized type of black hole ever discovered. Let's start. Starting with stellar black hole. This is where it all begins. A massive star, at least 20 times the mass of our Sun, burns through millions of years of nuclear fuel. Then, one day, the fuel runs out. Without the outward pressure of nuclear fusion, nothing is holding the core up. It collapses inward in less than a second. The resulting explosion, a supernova, briefly outshines the entire galaxy. What remains is a stellar black hole, typically between 5 and 50 times the mass of our Sun, but compressed into an object just a few kilometers wide. The very first stellar black hole ever identified was Cygnus X1, discovered in 1964, located about 7,000 light-years from Earth. Astronomers detected X-rays coming from what appeared to be a blue supergiant star. But the star was not emitting them alone. Something invisible beside it was pulling gas off the star, heating it to millions of degrees, and consuming it. That invisible object turned out to be a black hole, 21 times the mass of our Sun. In fact, Stephen Hawking bet in 1974 that Cygnus X1 was not a black hole. By 1990, the evidence had become so overwhelming that he was forced to concede the bet. Astronomers now estimate there could be as many as 100 million stellar black holes scattered across the Milky Way, most drifting silently, invisible, waiting, moving on to intermediate black hole. For decades, astronomers faced a strange problem. We had confirmed black holes on the smaller end, stellar mass up to about 50 solar masses, and we had confirmed monsters on the larger end, supermassive, millions to billions of solar masses. But the enormous range between 100 and 100,000 solar masses? Almost completely empty. These are called intermediate mass black holes, and for a long time, scientists were not sure they existed at all. Then, in July 2024, a study examined 7 unusually fast-moving stars near the center of Omega Centauri, one of the largest globular clusters orbiting our galaxy. The only explanation for how fast those stars were moving was an unseen mass pulling on them, a black hole of at least 8,200 solar masses. This was one of the strongest confirmations of an intermediate black hole ever recorded. Scientists believe intermediate black holes are the missing link, the stepping stones between the stellar black holes scattered across galaxies and the supermassive giants anchoring their cores. They likely form when stellar black holes in dense star clusters collide and merge repeatedly over billions of years, growing slowly, quietly, until they become something far more powerful. Now, supermassive black hole. Almost every large galaxy in the known universe has one. It's sitting at the very center, not orbiting anything, anchoring everything. Supermassive black holes range from hundreds of thousands to several billion times the mass of our Sun, including our own. The supermassive black hole at the center of the Milky Way is called Sagittarius, a star. It weighs approximately 4 million solar masses, compressed into a region no wider than our solar system. It sits 26,000 light-years from Earth. For years, it was completely invisible, hidden behind dense clouds of gas and dust. But in 2022, the Event Horizon Telescope captured its first direct image, a glowing ring of superheated gas surrounding a dark shadow. That shadow was the event horizon, the boundary beyond which nothing, not even light, returns. Supermassive black holes do not just consume, they shape their entire galaxy. Their energy drives winds powerful enough to push gas out of galaxies, regulating how many stars can form. Without them, galaxies as we know them would not exist. But Sagittarius A star is not the biggest, not even close. Stay with me, that brings us to ultramassive black hole. At the extreme upper end of the supermassive range sit objects so large they have earned their own category. Ultramassive black holes, those exceeding 10 billion solar masses. The record holder is TON 618, a quasar located 10.4 billion light-years from Earth. Its central black hole has an estimated mass of 66 billion suns. Let that register. 66 billion suns, inside a single object. Sagittarius A star, the black hole in the center of our own galaxy, is about 4 million solar masses. TON 618 is more than 16,000 times heavier than that. Its event horizon is so large that our entire solar system, from the Sun all the way to Pluto, would fit inside it, with room to spare. TON 618 was already this size just a few billion years after the Big Bang. Scientists still cannot fully explain how a black hole could have grown this massive so quickly. It may represent the upper physical limit of how large a black hole can grow. Beyond this point, its own radiation may disrupt the flow of infalling matter, cutting off its own food supply. TON 618 does not just challenge our understanding of physics, it breaks it. Next, primordial black hole. Every black hole we have discussed so far formed from something: a dying star, a galaxy merger, a chain of collisions. But what if some black holes formed before any of that? Before the first stars ever ignited, or before the first galaxies ever assembled? Primordial black holes are theorized to have formed in the very first second after the Big Bang. In those first moments, the universe was an unimaginably dense, chaotic soup of energy and matter. Pockets of this material may have been dense enough that gravity collapsed them into black holes instantly. No star required. First proposed by Yakov Zeldovich and Igor Novikov in 1966 and studied in depth by Stephen Hawking in 1971. Primordial black holes could theoretically range from the mass of a paperclip, smaller than an atom, to 100,000 times the mass of our Sun. They are one of the strongest candidates for dark matter, invisible, massive, everywhere, and impossible to detect directly. Here is what makes them truly unsettling. We have never confirmed a single one. But in November 2025, the LIGO gravitational wave detector recorded a merger event with source masses so small they may only be explained by primordial black holes. Fossils from the birth of the universe, still drifting through space after 13.8 billion years. On to rotating black hole. Here is something most people do not know. Almost every black hole in the universe is spinning, because the massive stars that formed them were spinning. And when a star collapses, it conserves its rotational momentum. The result is a Kerr black hole, named after mathematician Roy Kerr, who solved the equations for rotating black holes in 1963. A rotating black hole does not just sit in space and pull things in. It drags spacetime itself along with it. This is called frame dragging. Think of it this way. Imagine stirring honey slowly. Everything near the spoon gets pulled into the rotation, not because of the spoon's gravity, but because the honey itself is moving. A rotating black hole does this to the fabric of space and time. Near enough to the black hole, there is a region called the ergosphere. Inside it, nothing, not even light, can remain stationary. Everything must rotate with the black hole, whether it wants to or not. Cygnus X1, the first confirmed stellar black hole, spins at over 800 rotations per second. A point on its event horizon moves it close to the speed of light. Frame dragging is not just a theoretical curiosity. It was experimentally confirmed in 2011 by the Gravity Probe B satellite. a spacecraft precisely measuring the distortion of spacetime around our own rotating Earth. Now imagine what a black hole does to it. Now for binary black hole. What happens when two black holes find each other? They begin to orbit one another, slowly at first. Over millions or even billions of years, they spiral closer and closer, losing energy with every orbit. And then, they merge. On September 14, 2015, at 9:45 UTC, the LIGO detector registered something extraordinary. A ripple in the fabric of spacetime. Two black holes, one 36 solar masses, one 29 solar masses, had spiraled together 1.3 billion light-years away. In their final 20 milliseconds of merging, they released the energy equivalent of 3 solar masses, converted entirely into gravitational waves. At its peak, that collision released more power than the combined light of every star in the entire observable universe. And we felt it. On Earth, 1.3 billion light-years away.
The detector moved by a distance 1,000th the width of a single proton.
That was enough. That detection, called GW 150914, confirmed the existence of binary black holes and gravitational waves in a single moment. It opened an entirely new window on the universe. We are no longer limited to what we can see. We can now hear the universe shake. And finally, rogue black hole. We began this video with a question. What if there is a black hole drifting silently through our galaxy right now? That is not a hypothetical. It is almost certainly true. Rogue black holes have no galaxy, no star to orbit, no fixed location. They form when massive stars die in isolated regions of space, or when black holes are violently ejected from their galaxies during collisions. Once free, they drift through the universe completely undetectable. No light escapes them. No radiation marks their position. The only way to find one is to catch it bending the light of a star behind it, an effect called gravitational microlensing. In 2022, astronomers did exactly that. Using data from the Hubble Space Telescope, they confirmed the first direct detection of a rogue black hole, located approximately 5,000 light-years from Earth, found only because it briefly bent and brightened the light of a background star as it passed in front of it. Astronomers estimate there could be millions of rogue black holes drifting through the Milky Way alone, moving silently between star systems, passing through without warning. If one were heading toward our solar system, we might not detect it until it was already close enough to disrupt our planets. Rogue black holes are death from the dark. Silent, invisible, and utterly unstoppable.